Hey, what is up YouTube? Today I'm starting my Haxe tutorial 3, and as you can see, I got a webcam, so you guys can see my face and maybe connect with me better. I don't know, see how it works. Um, Today we're going to be talking about object management. I kind of hinted on that in the previous tutorial. I kept saying it'd be a bad idea to have like 20 variables for different objects because it's just not going to work out, you know, so let's hop right into it. Close my awesome background. So as you can see, I switched over to Flash Develop because I kept getting things from Sublime saying buy me, and I don't really feel like spending $70 right now. Maybe in the future, but we'll see. So yeah, I just went with Flash Develop. If you did my setup tutorial for Sublime, this should work out just fine. It's just when you go to create a new project, and I'm not going to be able to find it, of course, right now. There we are. Yeah, you're just going to go down to OpenFL project, and you'll make that and run from there. It's really easy, and then if you want to run, you can hit here, or you can change your compiler here. So I'm going to be going with HTML5 or Nico today. Flash should work, but I don't know, I like HTML5 and Nico. They're decent. So yeah, here's our main function, and you can see that there's considerably less code from last time. Last time we had all of our code on one source file, and now it's all gone. And if you're wondering where it went, it's because I put it in different class files, which is typically what you would do in a any programming situation. So if you look over here, there's the vector 2D Haxe file, or Haxe class, and over here we got entity manager, that's new, special player, that's not new, bullet's new, and asteroid is not new. Is it? I don't know. Either way. Yeah, and base draw entity, I think. Oh yeah, I didn't make asteroids at all for you guys last time, so I'm going to show you guys how to do that today as well, because asteroids are what we're going to be that's what we're going to be drawing a lot of, and it's going to be able to dynamically change how many are on the map at any given time, or on the screen I should say. There's not really a map yet. So first let me explain what's going on here, what I've changed. I added this handle input function to our class, and no, that was in there last time, I'm pretty sure. Yeah, we had a handle input. So yeah, you guys know how that's working. I have modified it though, so it behaves more like a typical asteroids game. Let me bring it over here. So this is what it looks like now. This is where you guys will hopefully get to today. And you can see it's actually, I'm only pressing W, and it's going towards the cursor. So it's not doing that weird WASD thing as it was before, where W was straight up and D was straight down. Now it's in relation to where it's the mouse cursor is. I'll upload the source code again. I don't really want to go over this code. This is just math. Yeah, vector and trig. It's not a big deal. You guys should be able to figure it out if you look over the source code. It's not a big deal. Okay, so first, let me explain the base draw entity. So the base draw entity is what all the entities inherit. And if you don't know what inheritance is, you might want to go look that up. Pretty much it means all these objects will have the same things. So anybody that... Oh, there's a deer outside. Hi, buddy. Okay. Yeah, anybody who has this base is inheriting this base draw class. They will all have the same variables and functions that are in the base draw class. So let's say I make person, and he inherits base draw class. He's going to have an update function, and he's also going to have a handle input function. And it has to have this parameter in it for that function to be properly inherited. Otherwise, the compiler's going to throw a fit, and it's going to be like, this isn't right. Oh, there's a whole family of deer out there. I'm sorry, I'm very easily distracted. There's like 3 or 4 deer out in the yard. But yeah, it's taking in all that stuff, and then as you can see, there's a set speed. Uh, that's pretty much, so yeah, you put in a speed, angle, blah. Oh, 4 deer. That's the whole dang family. Um, yeah, and then here's some just basic stuff that sets it up and gets it ready to go. This code is pretty much just to make it so the pivot point is in the center of the sprite that's being drawn, which just makes it easier to work with because if you're trying to grab a sprite by its corner and you try to rotate it, it'll go like this instead of where if you put the uh, what would you call that? The pivot point in the center. Now it's going to rotate like this. So, I mean, I hope that makes sense. Whatever. um, I'm sure you guys it'll make sense if you guys delete this code and you're wondering what's going on. That's what's going on. So yeah. Now, the cool thing about that is it makes it really easy to deal with all these different objects. So, because the thing is, Asteroid does like all the same stuff as the player class. And like all except the only difference is the player class has inputs to deal with, which is not a big deal. So yeah, you can see right here I have start pulse. That's different from set speed. I don't think I'm actually using that right now. I'll probably just get rid of it. There is a lot of deer out there. I've never seen this many deer. I'm really sorry. This is really distracting, but I mean, of course they show up right now as I'm starting my video, but whatever. Yeah, and you can see it's overriding the update function. This can actually be brought down. Let's see. Updates. So yeah, we can take this code, and since it's going to be the same for every single class that inherits this class, because no matter what, if we're trying to change this position based on its speed, we're going to be updating just like this. So let's take this code, Control X, go to base draw entity, and we're going to drop it in this function, Control X. And now handle input, since that can be different for every single class, it's overridable. All these functions by default are overridable, and by overridable I mean you can see here, where is it? Oh yeah, so override, yeah, handle input override, which means it's the same function, but each class that inherits this code, it operates differently. So when I call update on this one, it's going to go, oh, read this code, and I'm done. But if I don't override it, it's going to go all the way to the base draw entity, read that update function, and then it's done. But since I'm taking this code and I want that to be there, let's save that, base draw special player, and then we do super dot, and we're going to do update. Boom. And now we can get rid of this and this. Now it might behave a little differently. Control Enter. Start pulse is not valid. Oh, so I was using it. Okay. Control Enter. I don't know why it keeps popping up. Oh, I broke it. Oh dear. No, well, the player still moves, but the asteroids do not. Oh yeah, asteroid has to, either I can get rid of it right here, and then I'll be happy. So let's close that. Control Enter. There it goes. So now it's going to the base draw class, and it's, sorry, I keep looking down. I'm using my tablet, and I keep looking at my face instead of the camera. Yeah, now it's actually calling that the inherited update function, and as you can see, everything's moving really smoothly. And now you're probably wondering, well, how am I doing this besides inheritance? That's actually pretty easy to explain. So I have this thing called Entity Manager, which, I mean, it could be honestly anything. I'll just go over the code this time. I seem to take too long if I try to write it out for you guys. That just takes forever. So, yeah, if you don't like the way I'm doing this tutorial, let me know, and I can remake it eventually. And I'll just write through the code with you guys. I'm not using any of these. This is for a later tutorial, these sleeping lists. Yeah, so don't worry about those. But they do have a good purpose. So in here, let's start out with our main class. We're going to go in here and we're going to go start trace. That's nothing. That's just a debug stuff. Add our events. And now walls is just a vector 2D object. It pretty much puts a point in the bottom right corner of the screen and says, okay, if you're beyond this, you're out of bounds. I think borders is the same. Yeah, I don't know why I have two of them. Whatever, I don't need two of them. Get out of here. Yeah, and then it goes down to EM, which is Entity Manager, and that pops in this, which is this, and border, which is this right here. So let's go into Entity Manager and we'll see why we need those input parameters. So we got parent and tools, and we got our BDR for border. We take border, active entities, we create a new list. Lists in Haxe are kind of different. It's almost like a stack in C++, but at the same time it's not. It's kind of weird. I say that because you can't just grab out of the center of a list in Haxe. You have to iterate through it, like I'm doing right here. So, yeah, right here. So I grab the iterator object and then I have to loop through it. But let me start back up here. So active entities dot add player. Now I've added player to active entities, and since active entities has a base draw entity class that it's expecting, it doesn't care. Now I go down here and I try adding my asteroids. Oh, and look at that, since they're the same, they're inheriting from the same thing, same base class, it doesn't care. It just goes, okay, yeah, that's a base draw class because that's what it is at the bottom. So it doesn't care at all, and it realizes, oh yeah, these all have the same functions. So when I run my update loop, it's going to go, oh yeah, this is a base draw class. It has an update and it has a handle input. No big deal. And since base draw class inherits from sprite, it's able to go, oh yeah, you have an XY position. So if your X is greater than or less than the padding size of the border, that's what keeps the rocks and the spaceships from going way too far off screen that we'll never see it again. It just pops back up on the other side of the screen. Sorry. And that's what that code does. So that's really all I've done so far. I'll go into a little bit more detail. If you guys are done, you can quit out now or skip to the end, see if there's anything else good that pops up. But yeah, I'm just going to keep talking about it for a little while. And yeah, here we go. So if you're still wondering how I'm doing that effect that's given us the typical asteroids look or asteroids feel, so how it's going towards the cursor, not just up and down with by moving with acceleration like I've been showing you guys. I can show you how to do that real quick. I put it on my blog. I don't think anybody's really looking at it, but it's there. I kind of just made a quick article, and it explains how I'm doing it in like brief explanation, and then, or an overview I should say, or so then you guys can figure it out. But anyways, I'll go over it now to help anybody else who needs help with it. It'd be better if you figured it out on your own, but yeah, I'll show you how. So let's go to special player, which we're already here, and now we're setting our acceleration for the vectors. Now the amount of acceleration we're adding is multiplied by how many keys we're pushing down. So if we're pushing 2 keys down, we're adding an acceleration of 2, but that's 2 total, not 2 in a specific direction. So I could be holding A and D, and yeah, it's 2 acceleration, but they're canceling out to 0 because they're in opposite directions. And you can see it's doing that right here. So it's, if we're pressing W, set vector, rotate, reference, and rotate reference is just this dot rotation, so it's the rotation of the player sprite. So if you come down here, set vector, this could also be another inherited function in the base draw class, but it's not a huge deal, so I'm not going to worry about it right now. Although it would save some time later on, but you don't really want to clutter it up too much if you can help it. I don't know, it just depends on how you're feeling. So if you look here, we're creating a new vector. This is the vector that's going to be added to the acceleration vector up here. Alright, sorry about that. Wireless headset ran out of batteries, so let's get back to it. Yeah, so as I was saying, the vector 2D, this is the one that gets added to the acceleration vector. The way I make this work is I take the amount of acceleration and multiply it by the product, like the outcome of the cosine. Like if I wanted to get the x acceleration, so going left and right, I take this value, and right here with this big number, what I'm doing is I'm converting from degrees to radians, because Haxe only wants radians in their trig functions. I don't know why OpenFL and Flash don't use radians, because all their libraries use radians for any rotational calculations. I don't know why it's like that. It's kind of annoying, but if you need to convert, just Google radians to degrees or degrees to radians, and you'll get this number, and you just multiply it by angle, and that'll give you the degrees in radians. Yeah, so run it through this. If you wanted to make the acceleration greater for both of these, I could input something like, let's see, speed float, and then I come down here and I would just go speed times that, and I'd come over here and do the same thing. And that essentially is how you would calculate a vector for acceleration. But yeah, like I was saying, like math cosine, that is getting the x, and then sine is getting the y. So if you take out these speeds that I just put in there, that's literally saying we're going to take this acceleration of 1 for the angle of blah, and we're going to take that acceleration and we're going to bust it up between x and y. So you're getting a total acceleration of 1, but in a direction. If that makes any sense. If you guys have taken trig, and especially physics, you should know what I'm talking about. Yeah, I'm not amazing at explaining math, I just know how it works. So if you need something that works for breaking out vectors, this is your guy. What else is there to explain? I'm not going to explain that. That's self-explanatory. You just gotta read your way through it. The only tricky part is the fact I'm kind of implicitly grabbing the mouse position, and it'd be kind of hard to tell that it's getting linked. I'll tell you how that's happening. So mouse position, right here I'm declaring it, and if you go to, oh yeah, it's really odd right now. So what's happening is, to give that mouse position to the player, what I'm doing is I'm going because remember I handed in the parent, which is the main class. I go in here and player.lookAtObject equals parent.mousePosition. Yeah, it's kind of a hacky way of going around it. I got bigger plans for this. It won't be so nasty. Yeah, there's some really cool stuff, like cool ways of messing with stuff. What I plan on doing with the sleeping objects is when you're done with it, like say you shoot a bullet, it's going to go flying off the screen, or it's going to time out, or it's going to hit something. You're done with it. You're not going to be drawing it. It's not. It doesn't want to be. You don't want to be calculating its speed or trajectory or position. You just want it. You want as little things in the active entities list as possible. Otherwise, you're just going to be wasting CPU cycles, iterating over them, which at first it may not sound like a lot, but once you start getting to like the thousands of objects on your screen because you got so many sitting in the background that aren't doing anything, it's going to start getting really heavy, especially on mobile devices. And what we're going to be doing is we're going to be popping them out of this list and pushing them into these lists. So then, they won't be in the way of this for loop, or not that for loop, this for loop, because the least amount of loops you can do in this loop, or the least amount of iterations you can do in this loop, the faster your game's going to be, which is what every game developer shoots for. Another thing you should keep in mind, add child. It's literally placing stuff on top of each other. So if I add in this sprite, and let's say I add in an asteroid, now let's add in the player. Player's on top of asteroid now. I'll show you what I mean. So right now you can see how the player's on. Oh yeah, I forgot. I'm gonna sneeze. Or not. That awkward moment. Okay. Alright. So as you can see, the asteroids are all below the player. Now let's close that. And then let's see what it looks like when this line of code is before this line of code. This is where the asteroids are getting added to the main stage. So we're going to run that. Now you can see I'm behind all the asteroids now because they're getting added after me. So if you want something particularly to be on top, such as like a HUD or something like that, you want to add those in last. Yeah, because that does count. But you would you'd be wanting to add in like different states and stuff, which is something I can cover in a later tutorial. Yeah, you wouldn't want to be adding them into the same state or same screen, because you would have like, if I was going to do UI, I would have a whole different class that would get added in separately, and it'd probably be outside of the entity manager, and it would just be by itself, and it wouldn't be interrupted very easily by anything in the game, because it should be fairly separate from the game, and communication between them should be really controlled, or interaction between the game and the UI should be really controlled, because all that should be happening is updating player scores and stats. I'm running out of breath here, guys. Wearing me down. There's one more thing I was thinking about talking about. Probably gonna do like a big jump cut here. Oh yeah. So if you want to set up your project like this, you realize I have stuff in different folders and in different class files, which is really useful for organization. But the problem with that is Haxe is really picky how they do their packages, and I fell victim to this a couple of times when I was first starting out with Haxe. It's really frustrating until someone tells you about it or until you figure it out. But if you want to make a folder to put your stuff in and you want to label it with a package, which you should, because that's just good coding practice, you have to make sure that these folders and these package names start with a lowercase. And your class files always have to start with an uppercase. Otherwise, Haxe is going to freak out and it's not going to realize what's a package and what's a class. Don't ask me. That's just the way they did it. Every other language I've played with, it doesn't matter what's uppercase and what's not. But Haxe really cares about that. I don't know why. I'm not a compiler engineer. That was the other big wall I ran into, and I kept having issues with. A little frustrating. Yeah, especially with the Entity Manager. Entity Manager, for some reason, I still can't figure out why it's doing this. Maybe it's because it's misspelled. Ah. Curse you, poor spelling. Yeah, I see that. I spelled asteroid wrong. Asteroid. Ryode. Okay, so we're going to take that. We're going to replace this name. And now it shouldn't be. Yes. Let's go back to Entity Manager. We should be able to delete that now. Aha! Thank you guys, I figured it out. Thanks to your help. Awesome. But yeah, as you can see, it even took the file name into consideration for creating the correct package, which is really frustrating because I'm used to it, like with Java, C#, and C++. Yeah, C++. I don't remember. I haven't messed with that in a while. You pretty much just write how you want the package to be, and then the compiler goes, okay, that's the way it is. These guys are like, no, we're gonna implicitly make package names for you, but then you're allowed to name them too. I don't know. It's strange. But, yeah. I hope to have a tutorial back to you guys next weekend. Maybe a little bit more of a comprehensive subject. This is just a glaze over to, getting your objects on the screen, so we can start doing more fun stuff like collision detection and spawning in bullets and all that such and stuff. So yeah, I think that's it for today. I'd like to thank you guys for watching. Please comment, rate, and subscribe, and I'll see you next time. Bye.